Welcome to lesson 6, the particle equilibrium. So please pay more attention to this lesson because this is the content we will discuss today will be used for the following classes. Okay, so pay extra attention. So let's get started by example. How to solve the particle equilibrium equations. So for example, you have a box. Its width is 550 laps and the geometry is shown here. So you can see the box. We have AD, we have the cable AD, cable BA, and the cable AC. And we know the cable BA's angle to the horizontal line is 30 degrees, and we know the slope of the AC is 3/4. Okay, that is right or wrong. So the first, we need to find what's the force in the ropes AB and AC. So the first step is to draw a free body diagram for point A, and then apply the E of E to solve for the forces in the rope AB and AC. So what's the equilibrium of the particle? So for any particle, the sum of the Fx on that point will be equal to 0, and also sum of the Fy will be also equal to 0. Okay, that's a true equilibrium equation for the point for any particles. So let's go to more detail for this example. So free body diagram, we have for point A. Point A that has the Fd, which is the gravity of the box that equals to 550 laps, and also the cable AB has the tension to the point A. We show it and its angle to the horizontal line is 30 degrees. Okay, that's the direction of the FB. And for FC is from the cable AC. That's a tension from the cable AC to point A. And also we draw its direction by using the slope. So as I talked before, we have two equilibriums for a particle, which is the sum of the Fx equals to 0 and the sum of the Fy equals to 0. And we assume the direction of the Fx towards the right point, right direction is positive. And we assume the Fy, the upward direction is positive. Okay, it's our assumption. You can also make the opposite assumption. Okay, the results will be the same. But to simplify this process, let's make the assumption the right direction is positive and the up direction is positive. So our first equilibrium equation is sum of Fx equals to 0, which means the Fd is perpendicular to x, which means it's Fdx equals to 0. So we don't need to consider Fd when we are talking about sum of Fx. So Fb its component on the x direction will be Fb times by cosine 30. It will be negative because it's towards the negative position of the x. It's towards the left side. Plus Fc times by 4/5. Okay, this one will become 0. Okay, that's how we get this equation. And sum of the Fy equals to 0. Okay, it will be Fb times sine 30 plus Fc times by 3/5. Those two are all positive, okay, because it's upward direction. And the minus 550 each equals to 0. So that's how we get this equation. Okay. So based on let's call this equation 1, this equation 2. Based on the equation 1, we can know that FB will be equals to FC times by 4/5 divided by cosine 30. So that's how we express FB in terms of FC. And then we can replace FB using FC, and then we can solve the FC. Okay, as long as we solve the FC, we can solve the FB. Okay. So let's see another example. So the mass of cylinder C is 40 kilogram, and the geometry is shown as in this figure. The tensions in the cable DE, EA, and EB. So that's the three things we need to solve. So similar, what's the first step? We need to draw a free body diagram for point E and apply the equilibrium equation to solve the force in the cable DE, EA, and EB. So first, let's draw the free body diagram at point E. I have tension ED, which is the opposite direction of X. FEA, which is opposite direction of Y. Okay. So FEB, its tension will be 40 kilogram times by 9.81. That's the forces to hold the cylinder C. Okay, which is exactly the forces of the cable. So similar as we see for example 1, we need to apply the scalar of the E of E equation and point E. So first, the sum of the fx equals to 0, which becomes negative TE because TE is to the left side. TE's direction is to the left side. It's a negative. Okay. Plus 48 times 9.81 times by cosine 30 equals to 0. Okay, we can solve the FED will be times by cosine 30, which become this 340 Newton. So because FED is positive, this positive means the direction of AD is the same time we'll assume the direction of TED. So TED, our assumed direction is to the left side. Our solved is a positive 340 Newton, which means the FED is to the left side. So what about the sum of Fy equals to 0? It will be 40 times by 9.01 times by sine 30 minus TEA equals to 0. And we can solve TEA is 196. Okay. Let's do a very quick concept quiz. First, assuming you know the geometry of the three ropes, okay, in which system above you can now determine the forces in the cable. You can pause the video a little bit and think about the answers. Okay, the answer should be C. And why? Because for any point, we only have two equilibriums. So which means you have two equations. And we can solve two unknowns at most. Okay, for figure A, we have two cable, we have two unknown force, and we have two equation. It can be solved for sure. Cable B, it also has two cables. It has two forces, which is unknown, and we have two equations, which can be solved. But for the C, we have four cables. It has four forces, four force. We have four unknown, but we only have two equation. So we cannot solve four unknowns only using two equations. So which means the answer to the A to the question 1 is C, and answer to the question 2 is C. Okay. Okay, let's continue. For the example 3, the mass of the lab is 20 kilogram and the geometry is shown here. Please find the forces in this cable. So similar, we need to draw the free body diagram for point D and apply the equilibrium equation and point D to solve the FCD and FDE. And after we know the FCD, we can repeat the process for point C. So for point C, after solving the point D, we will know FCD. So for point C, the only unknown will be FAC and FBC. So we have two equations and point C and two unknown and point C, and we can solve it as well. Let's get started by solving this problem at point D. So I suggest you pause this video and please write down the equations of fx equals to 0, fy equals to 0 on your own handout or notes. Okay. The sum of the fy will be equals to fde times by sine 30, which is upside is a positive, and minus w, which is 20 times by 9.81. This equals to 0. And we can solve the FDE based on this equation. And for fx, it will be FDE times by cosine 30 minus FCD equals to 0. So we already solved the FDE, and then we can solve the FCD in this equation. Okay, here is the equation, and here is the answer. After solving at the point D, we need to solve the problem at point C. So because we know the FCD is 340, similar, sum of the fx equals to 0 and point C, we can get 340 minus FBC times by sine 45 and minus FAC times by 305 equals to 0. And the sum of the Fy also equals to 0. It will be FAC times by 4/5 minus FBC equals times cosine 40 equals to 0. Okay, you can solve these two equations and you will get the answers, FBC and FAC. Okay. Attention quiz. What's the correct free body diagram of the particle A? So answer should be D. So for the point A, we have three forces, which is the weight of the object and the tension from the two cables. Okay, that's why we have three forces at point A. Another quiz. Using the free body diagram of point C, the sum of the forces in the x direction will be sum of the Fx is equals to F2 times by cosine 50 minus 20 equals to 0. So the answer should be B. Okay, that's pretty much for today's lecture.